Hi everyone, welcome back. In this video, we will see two kind of data structures. One will be bitmap, another one will be a linked list. Guys, these data structures like bitmap and the linked list are used for to keep track of what are the various kind of freeholds and what are the occupied spaces in dynamic partitioning, right? So this concept actually I have explained in the earlier video. Anyhow, we'll see in depth about this bitmap and the linked list in this particular video. So which means that if I say there will be a main memory where some part is occupied with the operating system and the remaining part is going to be splitted as per the processes need, right? As it is dynamic partitioning, based on the request of the process size, we are going to allocate it. For example, let's say this size will be 5 MB, this size will be 7 MB, and let me take it as 3 MB. This will be 12 and this will be 14 MB, and assume that all are already occupied. All are already occupied. If all are already occupied, definitely after a certain point of time there will be certain process which will come back. For example, let me say this is P2 and this will be there P1, right? Let us say P1 and P2 are the process which came outside, right? When they came outside, I can represent the structure will look like this, right? So bear with me, this diagram OS, and P1 is free and this is occupied, and let me say this is free, and again this one will be a full and this is also full, right? So now how many holes are there? There will be 2 holes. And how many full space are there? How many occupied spaces are there? Total 3 occupied spaces are there, right? So in order to maintain how many free holes and how many occupied spaces, we have to come up with certain kind of solution, right? So generally, if you go with the static partitioning, let us say if we go with the static partitioning, what will happen? In static partitioning, we are going to have fixed number of partitions. Like there might be, if the partitions are of 6 partitions are there, then I can take a simple array where the array of size should be 6, 0, 1, 2, 3, 4, 5, 6. If the partitions are 8, then I can take array size as 8, 0, 2, 7. So if it is static partition, that is okay. But the problem here is we are working with the dynamic partitioning. In dynamic partitioning, we don't know exactly how many number of partitions are going to be maintained, right? So as these are varying dynamically over the time, we need to come across with these two directions. One will be bitmap, another one is the linked list, right? So let us check with the first one, which is bitmap. Guys, bitmap is a kind of a data structure which is used for to keep track of various kind of empty spaces and occupied spaces. If I know that what are various kind of empty spaces, I can able to place some other processes, right? For example, let's say there will be a memory. There will be a memory. The memory contains various kind of allocation units, like that. For each and every allocation unit, they can be partitioned like this. Let's say, right? So you can able to have multiple partitions where it can be look like this, right? Where every partition can contain certain data. Like for example, if I say some data is there, I mean, if you want to note down that, I have to have some parallelly one more kind of data structure is required, like array required, where this array will maintain all the data, right? So I can say in other words, here how many number of bits are there? bits are there, that many number of allocation units will be there. Right? Here, for example, if it is having some 100 allocation units are there, here definitely it should have 100 units. What will be the reason? For each and every partition I have to define whether it is free or not. Let me say the 0 represents it is a free hole. I can call it as a free hole. If I say this is 1, which means that this particular process is full. Right? So based on this thing, I can able to identify easily which locations are full and which locations are free. Right? So here the major problem what you have to understood is, right, depending on the size of the allocation unit, our bitmap is going to be depend. Am I right? Right. So as here the size of the allocation units are 100, the bitmap size is also going to be 100. Right. So that is the reason I can say that here memory is wasting, or I can say that extra memory is using. Right? So you have to avoid this kind of thing. Right? So if you are able to clearly understood, if I say something like its range is from 0 to 99 and 100 to 199 like that, if you want to maintain identify continuous zeros, if I am able to observe continuous zeros, then I can say that this is a kind of a free space, so that I can able to place the new process. But the thing is, if you want to identify the continuous zeros, right, it is going to take some time, right? So that will be one of the problem, and another problem is it is going to take extra memory, right? So to overcome these drawbacks, we will go with another kind of data structure which I can call it as linked list. Guys, linked list is a kind of data structure which is meant for to maintain or to monitor what are the various kind of free spaces and what are the various kind of I can call it as full spaces. Right? The another alternative for the bitmap is linked list. In linked list, what will happen? Na? Generally, linked list contains what? Everything we are going to represent in the form of nodes. Right? So let's say the node structure will be like this. Right? We are going to say this particular thing as a whole or a process. If it is a process, what is the starting address and what is the ending address? This is the thing, right? I can say this is starting and it will be the ending one, right? So let's say our main memory look like this. Initially operating system will be there, and let us say this is full and next one is free, and the immediate one is full again. This is free. If you observe, this is 0 to 99 and 100 to 199, 200 to 299 and 300 to 399 is already a free. How we are going to represent this structure in the linked list? So in the earlier bitmap, we are going to maintain the continuous zeros from 0 to 99 as ones, 0 to 99 as ones, so that I can able to understand that this is full, and I have to maintain 100 to 199 as zeros. I have to maintain 100 to 199 as zeros, so that I can understand that this particular place is free, right? But representing that or identifying the whole means identifying the continuous zeros, it is going to be a complex one, right? And which will take the more time. Instead of that, we can go ahead with the linked list representation, where, so what will happen here, the process is there and which is address is from 0 to 99, and next one will be a whole, the starting address is 100 and ending up with 199. Next one is what? A process, starts with 200 and ending with 299, and next one is again a whole, which starting address is 300 and ending with 399. The representation for this is like that, right? So guys, based on certain kind of simulation, they said that memory required for the linked list is less compared to the bitmap. That's why linked list is an efficient one compared to bitmap, right? So if you want to check with, if you want to insert something at the first location, basically you know that time complex will be big O of 1, and if you want to check with the last one, that the time complex will be big O of n, right? But if here, try to observe, if you want to make continuous allocations, if I say some process is allocated here, then what you can do, you can simply replace with whole with the some process. Or if you want to say this was freed, now I can make it as whole, so that I can able to merge these two as one, right? As we are trying to discuss with what partitioning, variable partitioning. So whole from 200 to 399, that will be like this, right? So some situations where it might have the addresses are in the zigzag order, so it's always better to maintain, right? In this particular example, we are maintaining the addresses in the sorted order only, right? 0 to 99, 100 to 199, 200 to 299, 300 to 399. We are maintaining the sorting order. But certain situations where the addresses might be maintained in some kind of zigzag order, right? If you are able to place the addresses in the increasing order of their starting addresses, it will be easy for us to merge, right? Merging is going to be very easy, right? As just now I have shown the example, right? And guys, if you are able to observe one more thing, I can able to move from one direction to another direction, means I am trying to move from left to right. If you want to have the more performance improvement, what I can do, can I go with some kind of double linked list? That's where it is easy for us to move back, right? So maintaining the double linked list is more useful, right? These are the two modifications that we can able to do on this linked list, so that will be better for us, right? So like this, we can use these two databases, bitmap and the linked list, for the tracking of freeholds and the occupied spaces. I hope you understood this video clearly, guys. Thank you.